This is an algebraic proof, and our goal is to prove that angle RSQ, which is this angle right here, is congruent to angle XYW, which is right here. Now, in order to do this, we need to prove that the triangles are congruent. And then we have to use corresponding parts of congruent triangles are congruent. When we're in a coordinate plane, it's nice because we can calculate distances in this case. Now, from the first triangle, RSQ, RS is the easiest one because it is a horizontal line. We don't have to do a Pythagorean theorem. We could just count them up. 1, 2, 3, 4, 5, 6, 7. RS is 7 units. Now for RQ, we can use the Pythagorean theorem by using the coordinates and using, well, not the Pythagorean theorem, but a distance formula. But the easiest way to do this is to drop the horizontal and the vertical and count them up. That's a 3, that's a 2. It's going to get you the same values from the distance formula. But now that we've created the right triangle, we can find RQ by just using Pythagorean theorem. So I know RQ quantity squared, because it's the hypotenuse, will be 3 squared plus 2 squared. So RQ quantity squared is going to be 9 plus 4. RQ quantity squared is 13. And I don't want RQ squared, I want RQ, so I have to take the square root of RQ is equal to the square root of 13. That's RQ squared, rather. So that means RQ is equal to the square root of 13. So I know this is the square root of 13. Now I have to do the same thing for QS. For QS, it's 1, 2, 3. It's 1, 2, 3, 4, 5. So I have a 3 and a 5. So SQ squared is going to be 3 squared plus 5 squared. SQ squared will be 9 plus 15. SQ squared is going to be equal to 24. So for SQ squared, I need to take the square root of SQ squared is equal to the square root of 24. And so I get this SQ is equal to the square root of 24. Now, a lot of times you want to simplify the square root to make it into something that's a little bit easier to work with. For here, we don't really have to. Now let's take a look at the second triangle. And let's try to find some corresponding parts in this case. So for the second triangle, I have XY is a vertical line. So XY, I don't have to deal with a Pythagorean theorem or a distance formula. I could just count the boxes. 1, 2, 3, 4, 5, 6, 7. So XY is equal to 7 units. Now I'm going to work on WX. And if I create the horizontal and vertical, I get 2 and a 3. That looks familiar for here. So WX squared is equal to 2 squared plus 3 squared. WX squared is equal to 4 plus 9. WX squared is equal to 13. So the square root of WX is equal to the square root of 13. So WX is equal to the square root of 13. So that's square root of 13. Now all I have to do is find WY. And in this case, I could drop the horizontal and vertical. That's a 3. 1, 2, 3, 4, 5. That's a 5. So WY squared is equal to 3 squared plus 5 squared, which should look familiar to this one. So wy squared is equal to 9 plus 15. Wy squared is equal to 24. So wy, the square root of wy squared is equal to the square root of 24. Wy is equal to the square root of 24. So therefore, since rs is equal to xy, rq is equal to wx. So rs is equal to xy. So that means the segment rs is congruent to the segment xy. I know rq is equal to wx, which means the segment rq is congruent to the segment wx, and sq is equal to wy, so the segment sq is congruent to the segment wy. It's important to go from equality to congruency, because now what we can do is we can say that triangle QRS is congruent to triangle. Well, Q is corresponding to point W. R is corresponding to point X. S is corresponding to point Y. And the reason is side, side, side. I was able to prove that all three sides are congruent to each other, and then I could say, therefore, angle RSQ is congruent to angle XYW, and the reason is by corresponding parts of congruent triangles are congruent. So an algebraic proof just means that we have to prove that the side lengths are equal to each other. And once they're equal, they're congruent. Once they're congruent, the triangles are congruent by side, side, side. And once the triangles are congruent, corresponding parts of congruent triangles come into play, and we can make the conclusion that angle RSQ is congruent to angle XYW.